In the previous video, we had discussed about resonance structures and how to draw them. If you haven't checked it out, or if you do not know how to draw resonance structures, first learn that and then learn about resonance effect. So resonating structures, as we know, are basically the ones which help us explain the various properties of a particular compound, especially the ones which cannot be explained by just one structure. So resonance effect is basically the polarity which is produced in the molecule, and this is because of the interaction of two pi bonds or between a lone pair of electrons present in the adjacent atom and a pi bond. So it's either between two pi bonds or it's between a pi bond and a lone pair of electrons. So similar as to how based on the effect it transmits to the chain, you have two effects, plus R effect and minus R effect. So plus R effect is basically tendency to donate electrons to the double bond or the conjugated system, and in case of minus R, the substituent withdraws the electron from the double bond or the conjugated system towards itself. So in case of plus R, basically these are going to be electron releasing groups, and we learned about few electron releasing groups. And plus R effect is shown by OH group, OR group, NH2 group, NHR, and Cl, Br, and I, and even actually NR2 group. So these plus R effect is basically these substituents have the ability to donate electrons. Now let's assume you have a structure CH2 is double bonded to CH, which is single bonded to a Cl. Now what happens is this has lone pair of electrons, and resonance effect is shown by interaction between two pi bonds or between a pi bond and a lone pair of electrons of the adjacent atom. So the lone pair of electrons on Cl will move this way, and this pair of electrons is going to move towards CH2, and this gives us another resonance structure, CH2 with a negative charge and CH double bound to Cl plus. Similarly, and if you notice, the number of electrons which are present are the same, the nuclei is not changed, so these structures are following the rules of a resonance structure. Another example would be aniline. Aniline is NH2 attached to a benzene ring, and we'd already learned about the various resonance structures of aniline in the previous video itself. Another example would be anisole. So anisole has a benzene ring attached to it, and a OCH3 group. And because oxygen has two lone pairs of electrons, one of them is going to take part in resonance. And this is shifting here, and then here you'll have a negative charge, the double bonds stay the same places, and OCH3 where oxygen will have a positive charge. Now this shifts, and then this towards the fourth carbon atom. So you have double bond, OCH3 plus, and then this shifting here, this is shifting here, this is moving here, this, and we learned in detail as to how to draw the resonance structures for substituted benzene compounds, and these are the resonance structures for anisole. Now here in this case, the electrons were donated by the substituent. So this is about plus R effect. Plus R effect is shown by electron releasing groups, whereas minus R effect is shown by electron withdrawing groups, or rather the substituents tend to withdraw electrons from the chain. So in minus R effect, the groups which show minus R effect include carbonyl group and aldehyde group, cyano group, nitro, COOR. All of these groups are negative, show negative R effect because they withdraw electrons from the double bond. So they are electron withdrawing in nature. Now, when these are present, so let's take the example of CH2 having a double bond, and this particular atom is going to be attached to a CN. So what happens is this double bond shifts here and this shifts here, and this leads to the formation of a positive charge on carbon because it loses the electrons, and CH double bond, C double bond, N. So, excuse me, number of electrons are the same. Now another example for this could be nitrobenzene. Now till now we learned about electron releasing groups, basically the ones which introduced an electron into the benzene ring and that was delocalized. Here in nitrobenzene, here you have NO2 and NO minus, nitrogen already has a plus charge, this has. Now in this case we will not be showing we can't write, okay, this is going to move here, this is going to move here, and so we'll have a positive charge over here and then nitrogen, oxygen. Now this is wrong. This is because in case of resonance structures, the arrow is only drawn, or rather in organic chemistry, no matter where you go, whichever reaction you write, the electrons movement is what is going to get considered, and the movement of the electrons is going to be denoted by this arrow. No other charge, only the electrons movement is going to be shown by the arrow. So this movement of positive charge is wrong. Instead, here also we'll be showing it with the movement of the negative charge only. So let's start. Here you have a single bond, nitrogen bonded to oxygen, this is bound to another oxygen, and so here you have a single bond, so this oxygen has a negative charge, nitrogen has a positive charge because it's bound to has 4 bonds around it. Now what happens is, so these are our double bonds. Now what happens is, this electron, the bond which is formed between these two carbons shifted towards the nitrogen carbon bond, and this bond is broken, and this leads to a negative charge on the oxygen. So basically, since this carbon atom is losing its electron, this is going to get a positive charge. So it has 1, 2 and hydrogen. So only 3 bonds. Because of that it gets a positive charge, and this carbon atom's tetravalency is maintained. Here the nitrogen atom gets a positive charge. Now both the atoms of oxygen are getting a negative charge. Now again we can't move the positive charge, but the negative charge, the electron of the bond is going to be the one that moves. So there is going to be a shift this way. Then you'll have, since that bond moved there, here you have a positive charge. Now this electron pair is going to move here. The positive charge is going to shift upwards. drawing resonance structures is really important. It helps you understand the reactivity of benzene when you learn about it. Now, what happens is one of the oxygens, either of the oxygens, their negative charge is going to be shifted downwards, and then this is going to get shifted here. That leads to nitrogen, double bond to oxygen, single bonded to oxygen. Here you have a double bond, and double bond. The charge has been maintained. So these are the resonance structures when you have an electron withdrawing group instead of an electron releasing group. So resonance effect is basically caused due to the basically the polarity which is produced due to the interaction between two pi bonds, or a pi bond and a lone pair of electrons. Now you have two types of effects, plus R effect and minus R. Plus R effect is caused due to electron releasing groups, or rather the electrons are donated by these groups, whereas minus R effect is caused by the groups which tend to pull the electrons towards themselves. And we drew resonance structures. If you want to again learn about resonance structures in detail, you do check out the previous video that I did about resonance structures, and the only way you'll be able to draw these resonance structures is if you practice them and understand the basic idea of tetravalency of carbon atom and why there's a positive charge, why there's a negative charge. So in the next video we will be discussing about hyperconjugation. Do check it out.